We're very honored to have Greg, Vicki, and Ian representing this project's Research and Data Gaps Working Group. Vicki, I think you're going to start things off.
So what I'm going to do is just go over what we have been busy with this past year, and that's finishing up this report on communicating recent pesticide research findings to inform stakeholders. The purpose of this report is really to compile and review relevant scientific literature. We focused on the period from 2010 through 2021 because basically it's a follow-up for the report that was published in 2009. The previous report, which was shared with many project stakeholders and the government's cabinet, and we hope that the same will continue for this one. So in this, we summarize the research for use. And again, we hope that it will be used not only by this conference, but state agencies, legislatures, and concerned citizens. Next slide, please. So what this provides is an overview of findings on key research studies, published literature, and also identifies data gaps. We provide 6 recommendations for potential actions to the Bay cabinets and other stakeholders. So we've summarized, and these are just brief paragraphs of summaries of the studies of over 25 studies that we felt specifically related to the Chesapeake Bay watershed. Next slide. What we hope is that these research findings inform strategies to reduce the impacts of pesticides on the Bay watershed and its life forms. As I mentioned, it's sort of summarizing research for the past 11 years. What we hope to do is not wait 10 or 11 years to get reports out, but to update this effort annually and keep current with the latest research findings that can improve both strategies and policies. Next slide, please. So just to give you an idea of some of these papers, I do want to emphasize that when I say we summarize 25 studies, as you might guess, there are hundreds of papers out there on pesticides and effects on various organisms, pesticides in soils, all those sorts of things. What we focused on was ones that we felt had the most relevance to Chesapeake Bay, even though they may not be or have been conducted within the Chesapeake Bay watershed. So each of us, Greg, Ian, and I picked a paper just to give you an idea of why we felt these were important and what's in the report. So my choice was a paper by Mahler et al. It was published in 2021 in Environmental Science and Technology, where they evaluated 108 parent compounds and 116 pesticide transformation products in small streams from 5 regions of the US. This is an example of a study that was not specifically done in the Chesapeake Bay watershed, but is very relevant. The findings are very relevant to what we are seeing. Transformation products or degradates of pesticides are formed by many processes, and so they'll vary depending on water quality, climatic factors, all sorts of things that affect those processes. What this paper found and others have found is that concentrations of these products often exceed the parent compounds. One of the studies that they actually cite in their paper shows that 70% of these are as or less toxic than the parent compound, but 30% are actually more toxic than the parent compound. But these compounds are not routinely measured. And so it is a data gap, I think, that it identifies. the graphs on the right-hand side of the slide are actually not from this paper, but are from some of our data collected within the Chesapeake Bay watershed. And it's just to illustrate that we are seeing the same things and that it varies from site to site. And I chose atrazine and one of the atrazine degradates just to illustrate. Within atrazine, we commonly measure 3 to 4 different degradates in the water. But what you can see is that our Antietam Creek site, the degradate, one of them was always higher than the parent compound throughout the year. And at some times, really achieving some pretty high concentrations, almost 1,000 nanograms per liter. At another site in the Susquehanna, you see a very different pattern where it's almost opposite. When the degradate is high, the parent compound is low, and vice versa. And so these are some of the complex issues that need to be teased out, and again, identifying data gaps. So this paper demonstrated, as do numerous papers that we evaluated, the importance of considering complex mixtures, importance of flow and other environmental factors, and the need to look at some of these degradates. So I am now going to pass it on to Greg, who's going to talk about one of his favorite papers.
All right, thank you, Vicki. So I'm going to just touch on another example here. This is Hartwell 2011. And the conclusion in this paper that was so interesting is that we know that the profile of active ingredients that are used on the landscape over time, and this is both in our developed landscape and agricultural lands, we know that over time, the profile of active ingredients changes. And this paper attempted to look over a period of time and using toxicity units, it normalized the amounts and the toxicity factors for known pesticides in use using the best usage data we have available. And through that toxicity unit method, reached a conclusion that while the quantity appears to be going down, if you convert to toxicity units, the overall toxicity is not going down. And so it was a novel method and a novel approach, and really helps us understand that this is a fluid issue in terms of what pesticides are in use, and understanding that helps us design our monitoring program so we can be looking for them in the environment, particularly in our surface waters. But it also shows us that it's possible that the toxicity, all taken together, can also change over time and maybe is not headed in a downward direction for less risk and less toxicity. And again, that was based on this novel approach of converting used pesticide amount and known toxicity to these toxicity units. So really interesting approach. And I don't think this has been redone since it was done a little over a decade ago. I personally think this is one that we should consider replicating and thinking about whether this approach and this method is something that we could repeat and see where it appears things stand now a little over a decade later. So because of that novel approach and all the way that it informs us, I think it's a really wonderful paper, and you can see even more details about it in our summary report that we're presenting to you today. So that was Hartwell 2011 example. And, you know, we're really lucky to have Dr. Hartwell still working with us and involved in the project. And so I'm going to get to hand it over to him now for a favorite paper of his. Ian?
Yep. Can you hear me?
Yes.
Yeah, I'm looking at a paper by Brett et al. From just a couple of years ago, and they were looking at the impacts of atrazine on the microbiome of oysters. And oysters, of course, are a really important species in the bay. Early European explorers were having trouble exploring Chesapeake Bay because they kept running aground on oyster banks. But anyway, so there's currently lots of efforts going into revitalizing the oyster populations in the bay with mixed results. But in any event, one of the things that Brett looked at was the effect of atrazine on the microbial community that lives in and around the oysters themselves. What they did was they just exposed oysters in batches to various concentrations of atrazine, and then followed them for several months. And what they found was that the impact of atrazine decreases the beneficial microbial community that grows around the oysters, and also increases the pathogenic species of microbes that grow in and around the oysters. So, and it affects apparently the growth rates of the juvenile oysters by impacting the microbial community around them and in them, both around them and in their guts and inside their shells. So the thing about the atrazine is that it is the most used pesticide within the Chesapeake Bay region. 75 million pounds, that's a lot. It's been banned in some places, like in the European Union, but it's still used extensively in the United States. So the impact is not only on the disease vectors that impact the oyster beds, but also the growth rates of the animals themselves, which in turn impacts the success of replanting. And I think I turn it back now over to Vicki.
Thanks. So just to wrap up the report from this working group, some ways you all can help out. If you know of any pesticide studies that relate to the Bay or that you think are important, please send them on. Also, if you know of groups that might benefit from either a briefing by one or more of us or a copy of the report, please let us know. And lastly, if you have an interest in this and you want to join us, we would love to have you help out. And the next steps that we will be doing are, as I mentioned, we will continue and hopefully put out some sort of annual summary of important findings regarding pesticides. And then we hope that this report will be finalized and published in January. Thank you very much.
Great. Thank you all. Very interesting stuff. And we're really excited about getting this report out there. I think it's going to be really helpful. So we do have time to do some Q&A with you guys. And we have a couple in the Q&A module. First one is, can you please explain toxicity units?
Yeah, well, I think Ian would be most qualified for that if he's able. Yeah, we're asked about toxicity units, Ian, and the method that you had in the paper for calculating those toxicity units.
Yeah, we basically it's the relative toxicity of a given pesticide for its concentration. It's very simple. You just divide the toxicity by the volume of pesticide.
Okay,
Okay,
great.
yeah. So I
All
hope
right,
that
we have
answered is a calculation that is taking the volume with the toxicity factor to come up with total units. And that normalizes the data so that we can look across all those active ingredients and make some assessment of overall toxicity and risk. So I hope that answers the question, Bonnie.
Okay. All right. I think this one may have pertained to the graphs that Vicky had shown. The question is, what is the x-axis in your graphs? 3 what?
That was actually the months. So we took monthly samples, surface water samples for that. And so 3 is March. And then in April and May, we had 2. We did it every 2 weeks. So 4.5 is halfway through the month.
Great. Thank you. All right. Here's another question. Have you looked at the interacting effects of temperature and other stressors upon the toxic effects?
Yeah, that's a really wonderful question. And my personal opinion is there is not very much data out there about what we can expect from rising water temperature and air temperature with regard to toxicity and synergistic effects of we know the fact is our surface waters are something of a chemical cocktail all the time. There are multiple potentially toxic chemicals present most of the time. And the question is, what's going to happen when surface waters continue to warm? Is there any greater synergy among those contaminants? And that's one example, I think, of needed research, maybe gaps in research. I don't know of very much that's happening with regard to what does climate change say about risk to our watershed with regard to chemical contaminants. It's not much happening that I'm aware of, but there are intriguing questions around it for sure. No, if Vicky or Ian has anything else on that.
No, I mean, I agree. There are a few papers out, not necessarily in the Chesapeake, that sort of begin to address that, but it's definitely a data gap. And, there's so many things to consider with rising temperature. Are there more transformation products? Are the fish or other organisms more stressed? There's, yeah, it's a big question, a good question.
Great. Thank you both. We have another question. Has atrazine effects on freshwater mussels been studied and any papers published?
None that I'm aware of. We could certainly look for that and get a response back. I'm personally not aware of any papers on atrazine toxicity to mussels.
Thank you. All right, here's another question. Have inert materials been tested along with and separate of the active ingredient?
Well, certainly that is part of the pesticide registration process, which assesses overall risk of the product, and there are allowable and not allowable additives for our pesticide formulations. And we hope that during the registration process that is considered and recognized, and that only approved and accepted additional elements are added to our formulations in addition to the active ingredients. So I think that happens during the registration process, that those additional ingredients are reviewed. As far as their toxicity, hopefully that there's a good foundation in that review that is based on known toxicity of those additional ingredients.
Great,
But I
thank
would
you.
also say that maybe a lot of times when we're monitoring, we're not necessarily looking for those inert ingredients.
Yeah.
Good point. Thank you. Here's another question. What do you consider the most important gap in our understanding of managing exposure to pesticides in the Chesapeake watershed?
Well, we don't benefit from an extensive monitoring network on this particular set of pollutants. It's very snapshot oriented in the way that we capture data about the presence of some of these pesticide active ingredients and their degradates, so that we can all come together to help understand what that might mean. Yeah, we do not have a network. In fact, we only had a couple of long-term data sets for pesticide monitoring in the watershed, and we're not sure that those have been maintained in recent years. So I would say the largest gap, and maybe it's not surprising, you put some scientists together, usually that's a question about we would like to have more, but we really have very scarce data and nothing longitudinal, nothing long-term that we can look for trends and make some other scientific assessments like that. So that's my pick for biggest gap in understanding conditions.
I guess for me, one of the things being a fish biologist is trying to understand the complex mixtures. And it goes along with what Greg said, is that we don't have all that information to know what the organisms are being exposed to. But then we also don't know, because, it's hard to do even exposures to complex mixtures. What mixtures do you pick? How many do you do? And it gets really expensive. But I do think that is something we need a better handle on, is how do these either act synergistically, additively, antagonistically, as far as effects.
Thank you. We have another question. Are there any studies in the report looking at the concentration of neonicotinoids in the bay and their impacts? She says she's especially interested because in the last few decades, seed treatment with neonics has gradually become the norm in field crops.
Right. Well, I think we have some toxicity factors that are available to us for neonicotinoids, helps us understand more about the relative risk from that group of active ingredients. What we don't have is a lot of data on presence, or sometimes we say occurrence. We just really, I don't know of papers on neonicotinoids in surface waters in Chesapeake Bay. Now, when we get these specific questions about a particular ingredient or a particular receptor that's at risk, like the mussel question, it really requires time to go jump into the literature unless by chance we know of a paper. So it may be out there. We just aren't aware, but boy, it's probably very sparse. So I think we understand more than we did a decade or so ago about the risk that's presented by neonicotinoids, but I'm not aware of much data on occurrence in surface waters. So that may be another data gap that we can identify. We can go look for papers, see if they exist, if there are any investigators out there doing that work. And if not, the question is that a high priority issue for us? And if so, how can we come together to get more data and do some monitoring and testing? And that's really, I think, an example of how this project was designed to work. We look for where there's data, we look for where there's gaps, and from that we make some decisions about how we can add value. And maybe that's one. So anyway, that's a response on that specific question.
Great. Thank you, Greg. We do have time for probably one more question. Do fish species differ in their response to pesticide exposure?
Hand that to our fisheries biologist.
Yes, the answer is yes. I mean, we find a lot of difference between species, not just even in responses to pesticides, but other chemicals as well. And some of it depends on their physiology. Some of it depends on their sort of life history, like do they spend more time close to the sediment? Do they spend more time up in the water column? You know, what are they eating? All those kinds of things go into it. But yes, we see big differences in responses.
Wonderful. Thank you. These are really great questions. I'm going to take these questions back to our research working group so we can continue to talk about some of the things that you all were interested in. And I thank you very much for that.